So welcome back, everybody, and also welcome back online. The last two topics that we are discussing today are also important pieces of our software-defined infrastructure. And the two topics that we are looking towards now in the next 10 hours, only 63 minutes, is the SUSE OpenStack Cloud and the SUSE Container as a Service platform. And also, needs to be mentioned that both are connected to each other already today and may also be more connected to each other in the future. So I will step by step go through both, and I again appreciate your questions. So most of you sitting here now know that we do an open source cloud product already, and that it is that this is part of your potential internal strategy to not only use a public cloud service, which is useful, but also may deploy the same interfaces and the same technology in your data center on premise, offer for your internal customers, or even offer to other people outside based on our technology. This helps obviously to build multi-tenant and scalable infrastructures, as we have described. And SUSE OpenStack Cloud is based on the OpenStack open source solution and community. And it is the leading open source cloud solution. There have been others in the past, but meanwhile, everybody basically aligned around OpenStack, which means that the OpenStack community is growing currently much faster than the classical Linux community, at least it was in the last years. Mostly this is deployed as an infrastructure as a service, IaaS, because these nicely fits in the infrastructures that already exist at most customers and most environments. Also, based on the situation that usually a certified Linux operating system is underneath, or a certified hypervisor. Also, most hardware platforms are available to be used with the OpenStack Cloud. As I said, it is a huge project meanwhile, and the OpenStack Foundation is managing all these, and more projects come into the game. From my perspective, the benefit of the SUSE OpenStack implementation is threefold, and probably this is my personal view more than any others. But let me try to describe it. First, we have a cloud environment which is and a cloud product which is built according to the same guidelines as our enterprise Linux product. This gives you a better guarantee for the code quality, and also repeated and repeatable builds. And this is what I tried to describe when we discussed SUSE Linux Enterprise before, that SUSE has developed a technology of building distributions of products and building Linux software in a very stable and very repeatable way. This is the heart of what SUSE does, and we have expanded this to the OpenStack framework as well. That's number one. Part of this is that we are also involved in the community, obviously. We have leadership people in the OpenStack Foundation, namely Alan Clark. The second point why I think the SUSE OpenStack project is so great is that we are really taking care about enterprise customers. I said that SUSE OpenStack Cloud and OpenStack environments in general are deployed as infrastructure as a service. This means that it fulfills the requirements of the Mode 1 as well as the Mode 2 people. And talking about the Mode 1 people, it is key to understand that these people, and remember that these people really are talking about long-term commitments, about stability, reliability, and high uptimes. And so if we're talking about this, then it is important that you have the uptime also on your infrastructure and not only on the application level. And this is what we will see later on, that there is a specific integration of high availability with our SUSE OpenStack Cloud product. And number 3 is the openness with respect to the existing environment where your OpenStack Cloud is deployed. SUSE OpenStack Cloud from the beginning has taken care about multiple hypervisors to be supported as the platform where the SUSE OpenStack Cloud product runs on. So we were the first to have multiple hypervisors, and I think it's missing here, but there should be, for example, that also VMware as a deployment deployment platform or an underneath platform for SUSE OpenStack Cloud is available. Not only open source, but true openness also includes that you are able to integrate with existing commercial environments. In addition to that, we not only provide on x86-64, but there's integration with other hardware architectures as well, as we will see later. And this is exactly what I'm talking about, that there is a free choice of the hypervisor that you want to deploy on your compute nodes, namely KVM and Xen, and also an integration into ZVM, so that you can use your existing Z as compute engines for an existing cloud environments. It's not KVM here, by the way, and it's really the ZVM, because we learned that the majority of customers who are interested in this want the ZVM integration and prefer this one. The other aspect of what SUSE always has been good at in the Linux area and also beyond is that we try to make deployment of infrastructures easy. And this also has been a benefit and also an investment area of SUSE OpenStack Cloud from the beginning, that we really take the software as it is, look at it, look at the pain points for customers to deploy it, and then make it easy to deploy. There have been some contests about how quickly you can deploy an OpenStack Cloud, and SUSE in the last years has always won this contest because our technology of deploying such an infrastructure is just leading here. So it's really easy to start with. I already talked about the requirements of an infrastructure as a service as a mission critical part of the infrastructure in your house. And as part of this, the cloud itself, the compute nodes might be redundant. But what is not so easily redundant is the management part of the cloud. So what we call the services cluster here. And what we have done in one of the last versions of SUSE OpenStack Cloud is integrate the existing high availability solution, so SUSE Linux Enterprise High Availability, with the open source CoreSync and Pacemaker technologies which are included there, into the services cluster, the head nodes of the SUSE OpenStack Cloud. So this means whatever happens to your management nodes, they are always there, even if one of those fails, so that you are reliable with that perspective. Is there a question? Okay, good. If there are questions, just raise your hand as usual, right? When you consider that there are 500 companies involved, then we also have to consider that there are multiple sub-projects of the OpenStack upstream. And not all of these obviously are in a state where they are supportable from an enterprise perspective. So it is important to consider which pieces of the OpenStack framework or the OpenStack open source offerings SUSE takes and integrates into the product. This is basically the explanation of the colors on the right side, so don't take this as as other modules. What we have added here as new technology previews is, for example, bare metal provisioning. It is an application catalog, secure or a key vault, and the database as a service. You see, these are new additions. What we also add, and this gives me a nice translation to the next topic, but we stay a little bit longer with OpenStack, is CaaS, so container as a service, because obviously you can run a container as a service platform also underneath of you can run it within an OpenStack solution, where you just use the OpenStack framework as a virtualization platform to run your container systems. Okay. As I said, from our perspective and also from my perspective, SUSE has added value to the OpenStack community, and SUSE has not added value but also enterprise quality and the qualification to deliver an enterprise product out of the community products and projects. This helps to build the infrastructures for other high-level application delivery platforms. In SUSE OpenStack Cloud 7, as a summary, we have fast and easy setup and management, as I said, award-winning, really. We have high interoperability with a number of hypervisors, not only the usual suspects of the community, but also commercial hypervisors like VMware and ZVM. We provide support for the entire bandwidth of modules available in the OpenStack framework. And we add the reliability and the high availability that you are used to get also from the SUSE Linux Enterprise world. One other aspect that is also requested quite frequently is the question of upgrades. So we allow customers to upgrade from one version to another in place, so in the existing framework. This is not necessarily given because the open source community obviously very often works on one release and then on the next release, and this transition from one to the other requires logic to be added to the product from our perspective so that the transition moves smoothly. Looking forward, as you are used to get, we have SUSE OpenStack Cloud 7, and if I'm not mistaken, also 8 has just been delivered. It's RC phase, yeah. So 7 is out in the market, and version 8 is in the RC phase. There will be a version 8 update later this year, which also adds a little bit more, for example, software-defined networking capabilities and a little bit more S390 integration, because we have actually customers who are requesting this. Version 9 of SUSE OpenStack Cloud is planned for 2019. And here we see inclusion of more SUSE Container as a Service platform capabilities into the product. And we also see, as we have seen with other platforms, and we will see soon also for the CaaS, that the product then in 2019 will be based on SUSE Linux Enterprise 15. So now it's based on SUSE Linux Enterprise 12 SP3 because that is the released and fully supported operating system underneath. And in the future then, that is the connection to the releases that we do on the SUSE Linux Enterprise side. That we building then the other products on top of this with a little bit delay because it needs a little bit qualification and development time here as well. Do you have questions to the OpenStack framework? If there are no questions, I go ahead, and now I'm lucky. I had thought that I have too many slides for the remaining container as a service platform. I'm aware that in the presentation of our partner just before, you already got a little bit insight into the structure and the logic of container as a service platform. So I apologize if there are duplications. Unfortunately, I didn't understand a lot of this Finnish. I just had seen the pictures, and some of those you will see here as well. But I hope that I can add a little bit value for you. As we said, Container as a Service Platform is an application delivery and a framework for us, orchestrating containers. I introduced this before, and I don't think I have to go through what containers are, but probably one of the most important aspects to consider is the question how applications are different when you are running them on-premise or in a traditional way, or if you are running them in a way of a containerized world. I think you have touched this. I heard microservices because that seems to be not translated in Finnish, as it is not in German actually. So from my perspective, this is the key difference when running a containerized world, in a containerized world, that you have microservices and that you, sorry, questions? Okay. And that you run cloud-native applications. Has this been discussed before, what a cloud-native application is, or what the characteristics are?
I think you can repeat.
Okay. So if you have a traditional infrastructure, you have monolithic applications which sit on a virtual machine or on physics. And usually these applications, specifically databases, but also application service or even web service, require that you always keep them up. You add high availability functionality to them. To database service, primarily you also add capabilities such as live patching, so that you are sure that these systems are always up, always running, and never go down. This is key, always up. Now, for a container infrastructure and so-called cloud-native applications, this is exactly the opposite is true. These applications are not meant to be always up, but they are meant to be always up to date. But this also requires that you can repeatedly restart them. So for a cloud-native application, it is key that it survives, that the application, the microservice, one of the microservices can be killed and restarted at any time. So this also has a consequence that some people's idea of just putting one of these monolithic things over there on the left side into a container and then containerizing the stack is not what you should do. Because just imagine you have a big database with terabytes of data and potentially using also terabytes of RAM, running this in a container and then just kill it. That will be real fun for the data consistency. A good database will survive that, but probably the recovery time will be significant. Now, so there is a key difference. Classic applications, mode 1 applications, always up, and you have to have a process and a defined procedure how to stop and restart these things. Cloud-native applications, mode 2, those you can always stop and restart. However, and this is the key argument, you have so many of those potentially, you may have 5 or 6 web servers which are orchestrated in a way that always 4 or 3 are up, that it doesn't matter if you just stop 2 of them. That is the key difference. And this also requires, and also this is important, this requires a different mindset for the developer. And this is where it requires a different mindset, but it also allows different strategies with respect to the application development. So that's important to remember. Monolithic versus cloud-native applications. The development that this enables is DevOps. It means that you can, and we have seen a similar with a colleague of Microsoft today, DevOps allows you to constantly review your application, potentially even restructure your application, bring in patches, and restart your application potentially 2 or 3 times a day. Do a new deployment multiple times a day. And this way, this is then the cloud-native approach, where multiple microservices working together and then bring the same service that in former times a big monolithic application brought. This, in an ideal case, this leads to reusable microservices, reusable elements, often provided as containers, in an ideal case. It's not always the case, so it needs an analysis of the application stack, of the goals and the architecture that you have. If you take this serious, and if you are aware of these different, the different attributes of the monolithic versus cloud-native applications, then you can go forward and say, how do I transform my existing stack from a monolithic classic approach to a cloud-native microservices-based approach? But please, don't put your big database in a container just to be containerized. Why are we so often talking about containers? Because containers give you an abstraction level that you did not have before. Without containers, you have an isolated development environment very often, and then you have a real challenge to bring from this development environment your application into the operational part, into production, because you need to adapt the operations to what the development team has done before. Yes, there is the other way around, that operations describes the developers what they should do, but this usually leads to, we cannot do this, we do not want to do this, and so on. So what it means is that here you run into blockers. On the left side, without containers, you may run into blockers with respect to innovation or with respect to speed of deployment, definitely. With containers, the goal is that you have a clearly defined interface, that is the boundary of the container, so that you can easily deploy what you have developed without asking the operations team to change anything. So you abstract the development environment from the deployment environment in a way that you just can deploy because you do not need anything on top of this. This also means that the developers are more happy and hopefully more productive going forward. To be able to do that on both sides and in the full development of cloud-native applications, you need to consider that nevertheless the full range of steps that you formerly have done throughout development, test, QA, and implementation needs to be done now on the container side. And this is why technologies like continuous integration and these feedback round that we have seen in the DevOps 8, that this is necessary because you do not have other steps anymore when going from development to production. And this is why planning, code, build, release, deploy, and operate are really not only a one-directional thing, but it's a multi-directional thing where each step influences the other. I have to admit, I personally don't like the word agile, because it gives you a notion that everything else would not be agile. That might not be true. There might be operations, there might be environments where you can be agile also with a classical deployment. If you have well-proven relationships between the groups. The promise of the containerized world is that these agility is easier to implement and is also scalable across organizations. So that means that you can work with outside people who deliver your container, who develop your microservices based on your requirements, and then you can deploy it independent of what these people have done within this container. Please keep this within this container in mind, because the within the container and outside has an important aspect for the long-term maintainability nevertheless. I will come back to this. So summarizing, containers enable the implementation of an agile development model and a DevOps-like model of deploying applications as microservices. We are aware that you cannot simply transform an existing monolithic application, but we have in mind that we need microservices, that these microservices most probably come in multiple containers, and these multiple containers need to be managed or orchestrated. And this is exactly the reason why it is not simply the case of deploying a container host when you want to run a microservices and containerized infrastructure. But the real point is that you need a way to look at your bunch of microservices as a stack of things that build your service, your application in the end to the end customer. So when we look at this, the container engine is just a very small part of it. What really comes around this is that you have an orchestration of all these microservices together. And what you also need in addition to this is you need to take care about the containers themselves. You need to take care about where the containers come from, where they are provided in your internal network. All this has to be automated, and also you want to do that in a way that is scalable with respect to geolocation, with respect to performance, with respect to reach. And one thing that is in the heart of it, and this is for a reason in the heart of it, is the life cycle of the container. And this is what I said some minutes ago. If you have different development groups who develop your containers, it is really important that you always are able to keep track what is in this container and that you are able to match the content of this container with upcoming security issues, for example. So there are these CVE databases where you can see this and that library may have a security issue, but it is key for you, if you have container-based infrastructure, that for every container you have a way to look into the container and find out if this container might be affected. If all your containers are development in-house, that is relatively easy. As soon as you are reaching out to other people or receiving containers from other people or grabbing containers from somewhere, then this becomes a challenge that you definitely need to look at and think about upfront before you start deploying. And this is why we say, in a little bit funny way here, that managing containers with just a container engine is hard, but that building a containerized platform which considers all these elements. Where do containers come from? How are they managed? How do I orchestrate my stacks? How do I orchestrate all these microservices together to become a real application is something that you probably want to be delivered by someone who understands how to deliver infrastructure. And this is where the SUSE Container as a Service platform comes in. It is an enterprise class container management solution and it enables, as we have just discussed, to easily deploy, manage, and scale the applications based on a containerized world. And the real thing is only containers. So the container as a service platform, the only thing that this thing does is dealing with containers in any way. There are 3 benefits in using these, let's say, prepackaged infrastructure for you. By installing it, you achieve a very fast access to a container-based infrastructure, because you can deploy it also like we did with OpenStack. The pre-deployment, the first deployment, is what we first looked at, so that you can easily install a small cluster to then run your container-based environments. And this also means that we pre-configure the more difficult parts of it for you, so that you can directly start with it. This includes that you have an easy-to-use web interface for managing your container platform. And this also means then that whatever you save with containers is not lost by investing more people into building your container platform, because in the end, you get from us, who understand building operating systems and similar types of things, you get from us this service in form of this product. So, what do we do? What packages do we include? What is the content, basically? So the content is that we have Kubernetes in there. That is the orchestration for your containers and your stacks. We have a container engine. We have an image registry, or you could say a container registry. And we're currently building this capability up, because that in the first version was a very simple one. Now we are really building a scalable registry. You have SUSE MicroOS, which is the operating system part of it. And we have other open source technologies such as Helm. I will have one slide about this as well. And I said before, we are building all of this based on the experience that we have gathered over the last years with SUSE Linux Enterprise and other products. So we have internal compliance standards that we are building all of our software with, so that we can go for example, common criteria with SUSE Linux Enterprise. The same build criteria apply to the SUSE Container as a Service platform. And we also assure that your platform is reliable and that it is scalable. So we test this. We have started with a small number of cluster nodes. At the moment, I think we are at 200 cluster nodes, and we may go even further depending on customer demand to really scale this out to a complete rack is already there. A rack would be, I don't know, 42 or 84 systems. That is easy to scale to, so we can already scale over multiple racks today with the Container as a Service platform. It has an efficient installation, as I said. It can scale, and it is always up to date. And remember this always up to date. I said before, the big difference between the classical Mode 1 and the Mode 2 world is Mode 1 is always up, and the container world is always up to date. And we translate this also into the fact that the Container as a Service platform itself should always be up to date. And this is what we basically have learned from these devices here. If you have a mobile phone, then what you usually get is you get a message here, update available, and then you click something, and then it downloads, and then it asks you if you want to reboot. And then you reboot, and then when you reboot, the update is applied, and then your mobile phone is again up to date. It's not up, but it's up to date. If you have two mobile phones, as I do, then you have basically the experience that you have with the Container as a Service platform, because this system will take care that not all the nodes, the cluster nodes, are always updated at the same time, but you're always reachable at one or the other line. So how we do this is that we have taken the experience that we had with SUSE Linux Enterprise and snapshots on Btrfs. We have taken this to the next step and deploy into such a snapshot so that you never affect the running system, but can at any point in time, using the orchestration engine, reboot single cluster nodes to be up to date. The default is once per day. That is completely different thinking than in a data center, where you would say, okay, once per half a year is probably okay to reboot. Here you say once a day, and it's no problem, because the infrastructure will take care, the orchestration layer will take care that you just have a running system. And this is what the three major components of the SUSE Container as a Service platform are built for and made for. I said it, we have the SUSE Micro OS, the operating system layer, the same core as SUSE Linux Enterprise, the same hardware service where it is certified on, the same technology to also apply updates and also apply potential hardware enhancements. We have a container engine which is configured using Salt. For cloud integration, it can also be pre-configured when deploying using Cloud Init. So this is also an integration that we have done, and this matches what I said before about SUSE OpenStack Cloud. And on the orchestration layer, we have Kubernetes. The microOS, a few more words here. I said already many of those. It's an easy to upgrade OS, always up to date. It is also easy to manage a cluster of nodes. We have added technology that makes it easy to just deploy another one. We use core SUSE Linux technologies to do the updates. And this might be surprising for some of you who have heard about other container as a service platforms or similar platforms. And real agile people might think, why are these stupid SUSE guys using RPM? Well, the answer is pretty easy. We have analyzed the requirements of such an operating system, micro OS, and such a container as a service platform. And we found that the capability to do transactional updates, so do an update without affecting the running system, and then just reboot and be up to date, and roll back if necessary, that this is what people really need, but nobody needs a new technology to just apply updates. And RPM is good enough to do what we want to have, because with these snapshots that we already can do, and actually nobody else on Linux currently does, could do but does not. By using this, so combining RPM with a snapshot technology, we exactly achieve what people want. And there is another benefit that we learned later on when we thought about this. I talked about hardware enablement. Who of you has heard about the SUSE Solid Driver program? Okay, only one. The SUSE Solid Driver program is a way for our hardware partners to work with us and deliver all their open source drivers for the Linux kernel in a standardized way, fully supported by the partner and us in an RPM format. And this allows the hardware partner to do same-day hardware enablement. This means when we now have the SUSE Container as a Service Platform 2 out here, and one of the hardware vendors comes with a special system which has a brand new network adapter. Let's take this. That's a very common thing. A new network adapter with the full power you can only use with a special driver patch. Then it might be that this vendor or this partner chooses to just deliver this as a solid driver update. It's a simple RPM. You can install it while booting, and the same technology, because we use this, can be achieved here. So this is one of the benefits. The other benefit, obviously, is that for future enhancements of the SUSE Container as a Service platform, simply packages from SUSE Linux Enterprise Server could be used. Currently, we are not encouraging people to do that because it comes pre-packaged, fit to the job. But there might be situations where you might want to do that. Think about debugging purposes potentially, where you then just install a debugging RPM to it. Because it's SLAS, you can do that. If it would not be RPM, you would have real trouble. So that's what we do here. And it also allows us to reuse other technologies, such as AutoJust. And you may think, AutoJust, really? Do I need this? Yes, you do. Because AutoJust is the way how SUSE Manager can interact with the SUSE container as a service platform automatically, because it just knows that already. So SUSE Manager can write an AutoJust file for this, and you can automatically deploy a container as a service also in an existing SUSE Manager framework. So there is some logic behind why we are using such old technology for such a new Mode 2 targeting product. We think that this is not old-fashioned, but that this is just a clever use of existing technology without reinventing the wheel every day. And that way, we can concentrate on the other factors such as scalability and making the transactional updates really future-proof. And that's what we have done. The real challenge for everybody, so should I say that this was no challenge? Probably yes. It was relatively easy to use a SLAS and then apply transactional updates. The real challenge is Kubernetes. It has two challenges. A, configuring Kubernetes is relatively complex. You need knowledge about Kubernetes, about the infrastructure. You need some infrastructure daemons running like etcd and so on. And the second aspect is that Kubernetes is quite quickly developing itself as an upstream project. I think it just came out of the incubation phase yesterday or the day before. So this means it's a real new project. It's in the baby phase. It has been in the baby phase. And so this means that the pain of pre-configuring Kubernetes was the bigger pain for us. On the other hand, this means for you that here in the pre-configuration of Kubernetes lies the real value of the container as a service platform, because you don't have to do a lot of this. All of this is done for you when you're installing your cluster. The network is pre-configured, the Kubernetes cluster nodes are talking to each other so that the Kubernetes orchestration engine can just start to work for you, and you can, using the web tools or the command line tools, so kube control, you can use to run your Kubernetes cluster and deploy, scale, and manage the containers or the stacks. Now, I always say stacks, and this is the last thing I would like to talk about. When we say stacks, then this means that we are looking at a group of containers together, which build a microservice application. Kubernetes itself looks at single containers still. And the Helm project, which uses Kubernetes, or is part of Kubernetes now, we could also say, this gives you the view of a stack here. So it's how it is configured is called a Helm chart. And my colleague phrased it this way. You see that down here, very small, that a Helm chart basically is the Kubernetes equivalent of an RPM file. And that is quite true. So it is a recipe of which pieces and which dependencies a specific stack has, which containers should be used there, how the network should be set up, and so on. And this you define, and you can, this way, you can transform and also migrate an existing application basically from one Kubernetes platform to another. And with this, that what we introduced in Container as a Service Platform version 2, basically from my perspective, we have really reached what customers need to run microservice frameworks. In CaaS version 1, it was container orchestration. In CaaS version 2, with the inclusion of Helm, you really have this stack view. You have the view of, I have an application. I don't have hundreds of containers, but this is application 1, application 2, application 3. And you can much easier manage this. And the trick is that Helm really is an upstream project, so it's nothing that SUSE just does, but it is part of the upstream development, and we are using that and contributing there as well. And now, building the bigger picture, I would like to go to. Should have done that. Building the bigger picture, you can imagine that here are multiple stacks on this screen that probably SUSE is looking into how to containerize those. Probably it was in the Finnish text that I didn't understand, but the obvious choices to look at are the platform as a service. This is actually already using Helm. So basically the integration of the container as a service platform with the cloud application platform is using this stack approach and Helm charts to describe what the CAP product does. But the next two that we are looking to internally are the SUSE OpenStack Cloud and the SUSE Enterprise Storage, and the teams are looking into if it is possible to containerize these two so that in the end you would not only be able to deploy the SUSE CaaS platform as a container platform on top of SUSE OpenStack Cloud, but you could also think that in the future, potentially, we would deliver SUSE OpenStack Cloud as containers on top of the SUSE CaaS platform. And no, I will not answer if it will be possible to do that like a Russian doll, where you then have a CASP and a cloud, and a CASP and a cloud, and no, probably not. But in the end, this could be quite interesting also in terms of deploying multiple things together. If you think about the container as a service platform as the least common denominator, where you could run an OpenStack Cloud, an enterprise storage, and a cloud application platform basically in parallel, all based on the same underlying technology, the container as a service platform. That said, a little bit outlook into the future of it. You see here a much faster pace than the pace that we have in the SUSE Linux Enterprise world. So basically, 3 releases per year this year are planned. We have a version 2X that's a little bit of a facelift of it. Then we have a version 3 mid-year and a version 3 plus or 4 that is not yet fully defined end of the year, where we really increase things. And you also see that the version 3 comes around 15, potentially a little bit earlier, so that here at the end of the year, we also will build the container as a service platform on top of SUSE Enterprise 15, and it will benefit from the new technology used there. You also see on this slide that there are thoughts about bridging mode 1 and mode 2 also in the CaaS world. You see down here LTSS. So this is something that we are currently looking into. It's not committed, but it's an interesting idea to think about the container as a service platform itself more being mode 1, more traditional, more infrastructure, long-term thinking, while the stuff that you run on top of it is more short-term thinking, more mode 2, more agile. And by doing that, we probably could bridge the worlds and also make it easier for you to deploy this and to maintain this. And with that, I would like to thank you for listening, and would be happy if there are some more questions. Yes?
CaaS is mostly about the application platform. So micro OS is the base of those containers. And is there tooling available at the moment to create micro OS based containers, or what's the roadmap on that?
So yeah. So the question is, if when we talk about macOS as the operating system in the SUSE Container as a Service platform, how do I create containers for it? The answer is very easy: use SLES. So SUSE Linux Enterprise Server has a container engine, has the development tools, so you can just use SUSE Linux Enterprise Server to build containers. And these containers then will run on the SUSE Container as a Service platform. As I said, it is exactly the same software stack underneath. macOS is the twin of SLES, actually. So I think the difference is 5 packages, and those 5 packages are in the area of Kubernetes deployment, transactional updates, and something else. It's not really a lot, and not affecting any APIs or so. So that is really the advice. The second option that you have is using the Open Build service. If you have open source tools, you can use the Open Build service that I talked about before to directly create containers from these framework for open source tools. Also, this has a knowledge about SUSE Linux Enterprise. You can choose there, so that is available. Does it answer the question? Not really? Yeah. Other questions? That is a build service enhancement, yes. Yeah. Yeah. Other questions? Okay. If not, then thank you very much.